2. So log into your lab canvas. Go down to Lab 02, Elements, Compounds, and Mixtures. This is where your lab archives notebook. Click on it to complete your lab report. Videos, Experiment 2, where is the lecture videos. You need to watch this to understand the difference between elements, compounds, and mixtures. And the last one is the lab quiz number 2. So after you submit your lab archives submission, and you're supposed to take the lab quiz. So we need to start lab archive first after you watch the videos. Then under experiment number 2, you need to read the introduction first. Introduction. So the purpose of this lab is getting familiar with elements, compounds, and mixtures, also their properties, vocabularies. So make sure while you're reading the introduction and doing the experiment, you gain the understanding, the definition of pure substance, elements. So basically all the elements from your periodic table are all simple are elements, and compounds. The mixtures. There are 2 different types of mixtures, heterogeneous and homogeneous mixtures. So make sure you know the difference between the 2 types of mixtures, families or group. So all the elements on the same columns are considered same families. So all the elements belong to same horizontal line, consider same periods, and make sure you know the difference between metals and non-metals elements. Tangible, malleable, ductile, and luster. These are 4 properties of metals. We also have a list of properties of non-metal elements. You're gonna see them later. So this, if you click on this one, it walks you to the PDF files. I have posted this same PDF file on your lecture canvas. This is a list of elements you need to memorize. So on your lab quiz number 2, you are given some of the element names, and then you have to write out the symbols. Or some of the symbols are given, you have to write out their names. So make sure you memorize this list before you take the lab quiz number 2. Okay. The next part, classifying of matters. So all matters is gonna be classified under 2 different categories: pure substance and non-pure substance, which is mixtures. So mixtures is any type of combination of more than one substance. You will have the mixtures. So under pure substance, there are 2 different classes: elements and compounds. All the simple from your periodic table consider elements, and they are pure substance. All the compounds. So if you have only one compound, it considered pure substance. Under mixtures, there are 2 different types of mixtures: homogeneous and heterogeneous mixtures, based on their appearance. So homogeneous mixtures, they're gonna look uniform and they're gonna blend well together. While heterogeneous mixtures, it doesn't look uniform, it doesn't blend well together. They have different spots, different patches. So elements, if you look at this periodic table, you're gonna see all the blue boxes located to the left of the zigzag line. So all the blue boxes are considered metal elements. So all of these elements are metals, and all the yellow boxes are considered non-metal elements, and most of them are located to the right of the zigzag lines, except hydrogens, which is non-metal and is located to the left of periodic tables. And all the green boxes are considered metalloid. Metalloid look like both metal and non-metals. So here are properties of metals: metallic luster, good conductor, soft and not brittle, ductile, malleable, tangible, while non-metal elements have opposite properties, characters. They are not good conductor, they are brittle, not ductile, not malleable, not tangible. So distinguished between metal and non-metals by appearance. Most of metal will have shiny looking, while most of non-metals elements we have dull looking. For example, carbon doesn't have that shiny, it's gonna dull look compared to copper, it looks shiny. Compounds. So we're gonna learn different type of compounds in the next couple lecture. But in this lab, you're gonna distinguish the difference between elements and compounds. So any compounds is combination of more than one type of element chemically bonded together, and it forms one type of compounds. In opposite, different than compounds, we have elements. So all the simple from your periodic table are considered elements. There are 7 types of diatomic elements. They are combined chemically between 2 identical particles bonded together, and it's called diatomic elements. So for example, O2, F2, N2, Br2. So review your lecture notes to know there are 7 different types of diatomic elements. And the last part, you're gonna learn different type of mixtures, homogeneous, colloidal, and heterogeneous mixtures. And then one more type of mixtures called solution. Aqueous solution, which is every time you have the substance dissolved in waters, you will have an aqueous solution. For example, you have a spoon of salt or sugar dissolved in water, you will have salt or sugar aqueous solution. So by appearance, homogeneous and colloidal mixtures, they are look like pure substance. They are look uniform, blend well together, while heterogeneous mixtures, it doesn't look blend well, it doesn't look uniform, it look different layers. Okay, so for the experiment where you need to fill out, complete your lab report. So the first table you need to do is Table A, identify elements, compare and mixtures. So there are different types of materials given in this table. You take a look at their appearance and type in your answers here. So you need to type describe of your sample and appearance and identify, is it pure substance or mixture? Is it an elements or compare, or is it a mixture, homogeneous or heterogeneous? So for example, we try waters. So waters appearance is look blue or colorless. State of matters, which is it solid, liquid, or gas? So in this case, water is liquid. And appearance, so water based on the pictures, it looks uniform throughout. It doesn't have different patches, so it's gonna be homogeneous. And is it pure substance or mixtures? So water is made up by H2O compounds, water molecules. H2O is water molecules. Oxygen chemically bonded with 2 hydrogen atoms, and H2O is chemical compounds. H2O is a chemical formula of waters. So it's gonna be pure substance. It contains only one type of compounds. And since it's made up by 2 hydrogen and 1 oxygen, it cannot be single element. It has to be compounds. And it's not a mixture. So another example you can try is rock. So you're gonna type in your answer in here. Rock, you look at these pictures. So based on the picture given, you're gonna see different patches. It looks solid and it have different patches, gray and black and purples. So basically, the appearance is many colors based on what you see. It could be gray, it could be black, it could be purples, and state of matters, it's gonna be solid appearance. So it doesn't look uniform throughout. So it has to be heterogeneous for rock. And substance, is it pure substance or mixtures? So since it looks heterogeneous, it had to be mixtures. It cannot be pure, and it had to be heterogeneous mixtures in this case. And you can try copper sulfate solution. So based on these pictures, you're gonna see copper sulfate. It look blue solution. It look blend well together. Look uniform throughout. Top, bottom, look surrounding, they all look the same. So based on definition, solution is the type of homogeneous mixtures. So in this case, you have copper sulfate compound dissolved in water. So copper sulfate solution, color is blue, state of matters, gonna be liquid, appearance, based on the picture, it looks uniform throughout, so it's gonna be homogeneous, and it cannot be pure substance. It has to be mixtures because it contains copper sulfate and waters, because we says it mixed with water, of copper sulfate in waters, and it contains more than one type of compound, copper sulfate and water compound. So it's gonna be mixtures, and it looks uniform throughout it, so it's gonna be homogeneous mixtures. So you're gonna complete the last one, carbon, and complete the table. Make sure you hit save before you move to the next part. So based on this question, you're gonna pick one of the answer. Is it can or cannot? So you pick one of this. Okay. So this is given for you. Based on your explanation, you can or cannot tell if the sample is a mixture by looking at it, because so fill in the blank. Okay. Elements. So the list of elements is given, and also their pictures attached at the bottom. So you're gonna describe how does it look like. You're gonna write out, fill out its element, symbol, atomic number, and their appearance. So let's start. Let's example with zinc. So zinc, it look silvery, shiny. That's appearance, and it is solid, so shiny in color, which is silvery. Element symbol and atomic number. So how you're gonna find this? You have to look at zinc from the periodic table. So zinc from the periodic table, which is Zn symbol. So this is the symbol of zinc, and atomic number, which is the number located on top of that symbol. So zinc, Zn, and atomic is 30. And fill that appearance. So next example you can try is phosphorus. So phosphorus, which is this red powder. So it look powdery, solid, powdery, red, and it look blue, not shiny. Phosphorus symbol, which is P, and based on the periodic table, which is this one, P, and atomic number is 15. Do the same thing to complete the rest of the tables, and move to the next step and move to the next part. Elements and periodic tables. So basically in this one, based on the periodic table given, you're gonna annotate. You're gonna put a green circle on the elements that are shiny, and put the blue diagonal line across the symbol, those that have do's. So based on this element, I'm gonna find them. So let's try zinc first. Zinc, copper, zinc, copper. So based on those two zinc, copper elements, I'm gonna complete this table. I'm gonna find them. I'm gonna put the green circle around zinc and copper and the rest of other elements. So put the green circle. So I pick this circle and change the color to green. Let's say this green, and fill color. I don't want to fill too much. Okay, there you go. Right, so I'm gonna drag the circle, and you can use this arrow to move the circle zinc around the zinc symbol, and copper, which is Cu. Where is copper? Zinc and copper right next to it. So I also put the green circle around copper. So you can do this one. If you make something wrong, you also can use this eraser to remove what you just made. And after you finish annotation, you make sure you hit click save annotation, and it's gonna auto save it to your lab notebook. Okay. And right. So move to the next part, metal and non-metals. So based on your annotations, you need to find out the location of the metals. Is it to the right or to the left of the step line? So you pick one. Same thing with non-metals, right or left of the step line. Pick one, right or left. And prediction of appearance of other elements. So based on your understanding, the difference between metal and non-metals, you need to make you will do some predictions. So there are 4 different types of elements given here: boron, lead, chromium, and iodide. So firstly, you have to find is it metal or non-metal based on their location. So let's try with iodine first. So iodine, which is symbol I, so which is right here. So based on its location from the periodic table, I predict it is non-metal. It's supposed to be non-metal because it stays to the right of the heavy step line. Then since it's non-metal, I should predict this is have the property of non-metal, which is dull, not shiny. Shiny is a property of metal elements. And now after I predicted, I'm gonna take a look at the observation, which is the picture provided here. So iodine, the picture given here, it doesn't look out. It looks kind of shiny, right? So it's up to you. Doesn't matter what you feel. You should put it here. And if your prediction match with the observation, you're gonna put yes. If your prediction not match with the observation, which is the picture provided, you're gonna put no. And reasoning, so there are 4 different types of reasoning. You're gonna pick from A to D, so read which one it matches with your reasoning, and you're gonna pick A, B, C, or D to complete this. And the last part is the magnetism and metals. So you're gonna use the piece of magnets to test different type of material you're gonna find around the house. You can find different materials. It's not listed here. You can put a name here and test if it's attracted to the magnets. So you're gonna find a piece of magnets. Any piece of magnets should work well in this experiment. You can use the refrigerator decoration. So use it to test different type of materials around the house, or you can use a phone holder with a magnet to test. You're gonna test, is it attract or not attracted to the magnets, and is it attracted to the magnets, you're gonna put positive. If not attractive to the magnets, for example aluminum foil, you put negative. And somehow partially attracted, you're gonna put partially, and yes, no, or partially in the next question. Compounds. So there are different types of compounds that are going to be given in this table of part C. Potassium dichromate all the way to iron sulfate. So the name given and the formula compound also given. So based on the picture provided, you're going to describe of your compound. So for example, potassium dichromate, it looks red, solid, granular, and a symbol of element contained in this compound. So it contains K, which is potassium, Cr, which is chromium, and oxygen, which is oxygen, O, which is oxygen. So how many of each element? So it contains K2, which is 2 element K contain, and 2 chromium and 7 oxygens. Let's try ammonium iron sulfate. So based on this chemical formula, make sure you describe it first. So ammonium iron sulfate, which looks solid, yellow, pale, dull, so not shiny. And the compound, the simple contained in this compound, which is nitrogen and hydrogens, irons, sulfur, and oxygens. And how many of each? So 1 nitrogen, 4 hydrogen, 1 iron. So SO4 inside the parenthesis with number 2 outside. You need to distribute it number 2 with S and O4. So there are 2 S, and oxygen 4 multiplied by 2, so which is mean 8 oxygens. And do the same for the rest of complete this table. Move to the next part. Properties of iron, and sulfur, and FeS. So you given different type of materials, elements of iron, element of S, and mixture of Fe and S, and compound of FeS. Then you're gonna describe its appearance based on the picture given. So for example, iron, it looks silver, looks solid, looks shiny. Sulfur, it looks yellow, shiny, solid. And Fe and S powder, mix it together. And iron sulfide, which is this piece of substance. So you need to know the difference between Fe and S and FeS, what difference between them. So in Fe and S, which is you have 2 different elements, pure substance, mix it together in a mixture. So you have Fe mixed with S in the mixtures. FeS, which is Fe chemically bond with sulfur in one compound. So this is one pure substance, one compound, chemically bonded together. This one, Fe and S, they just separate, they just mix it together, they just blend together, but not chemically bond between Fe and S. They're not making into one compound in FeS. Okay, so based on the appearance described here, and then attracted to magnets, yes or no. So you're gonna take a look at the second set of table. So here are S, Fe, and Fe and S and F, and then they test with the magnets, and you can see when they hold the magnets in the sulfur, it's not attraction. So sulfur not attract, no attract to magnets. While Fe attractive to magnets, and Fe and S, Fe attracted to the magnets, while sulfur is not attractive. And Fe and S compounds not attracted to the magnets at all. Basically, they can use this property to separate Fe from the sulfur. So they can use a magnet to separate Fe out of the sulfur mixtures. And the last part, the picture provided for you to see if four of these compounds sink or float in water. So based on this first picture, you can see sulfur floating on top of water. Iron, the nail here made from iron, sink in the water. Fe and S. So Fe sink and sulfur float. So basically they can use this property also to separate the sulfur from the iron. And the last one, FeS compound. You're gonna see when we mix FeS compound in waters, it turns into the colloidal solution. So you're gonna see this small particle floating around water. So they not partially float, or they not totally completely sink. So they floating around in water. That's the property of FeS solution. So completes the table. Then he submitted. Then take the lab quiz. Good luck everyone. If you have any questions, make sure you can drop me a text message in Bronto or send me email. Make sure every time you complete each section or each table, hit save. And before you complete everything, make sure you hit the submission buttons.